Look closely at our planet. Beneath the seemingly stable ground, immense forces are at work. The Earth isn't just a solid sphere, it's a dynamic, living entity. Sometimes it breathes, not with air, but with fire. From its deepest core, through miles of rock, molten material can rupture the surface in an explosive, often devastating display. These are volcanoes, and when they awaken, they remind us of the raw, untamed power that sculpted our world and the constant geological ballet happening right beneath our feet. Today we delve into what happens when the Earth truly breathes fire. To understand volcanic eruptions, we must first grasp plate tectonics. The Earth's outermost layer, the lithosphere, is broken into massive pieces called tectonic plates. These plates are constantly, though slowly, moving. They drift across the planet's surface, riding on the semi-fluid asthenosphere beneath them. Most volcanoes form at plate boundaries. When plates collide, one can slide beneath the other in a process called subduction. This creates an environment where rock melts, forming magma. This magma then rises, seeking weaknesses in the crust, eventually leading to an eruption. Other volcanoes form where plates pull apart, like at mid-ocean ridges, or even over hotspots, fixed plumes of magma rising from deep within the mantle, far from plate boundaries. The type of eruption depends on several factors: the magma's composition, its gas content, and the pressure building beneath the surface. Some volcanoes ooze lava gently, others explode with catastrophic force, capable of altering landscapes and climates. They are windows into the planet's interior, powerful reminders of geological time and potential threats to human life. When a volcano begins to awaken, there are often warning signs. Small earthquakes occur as magma moves through the crust. The ground might swell or deform. Gases like sulfur dioxide and carbon dioxide can escape from vents, sometimes in increased quantities. These signals are monitored by volcanologists to predict potential eruptions. Once the pressure exceeds the strength of the overlying rock, an eruption begins. This can manifest in several ways. Effusive eruptions are characterized by the relatively gentle outpouring of lava. This typically happens with low viscosity, basaltic magma, which flows easily. Think of the Hawaiian volcanoes, Kilauea or Mauna Loa. Lava flows can be slow, giving people time to evacuate. However, they can still destroy everything in their path: homes, roads, and infrastructure. They can also create vast new land masses as the lava cools and solidifies. Explosive eruptions, on the other hand, are far more violent. These occur when magma is highly viscous or sticky and rich in trapped gases. The gases cannot easily escape, building immense pressure. When the pressure is finally released, it can shatter rock and propel volcanic material high into the atmosphere. One of the most destructive aspects of explosive eruptions is the ash plume. Fine particles of rock, volcanic glass, and minerals are ejected miles into the sky. This ash can travel thousands of miles, disrupting air travel, coating cities, collapsing roofs, and damaging crops. Breathing volcanic ash can be harmful to lungs. Another deadly phenomenon is the pyroclastic flow. These are fast-moving currents of hot gas and volcanic debris, superheated to hundreds of degrees Celsius, that can rush down the flanks of a volcano at speeds exceeding 100 kilometers per hour. They incinerate everything in their path and are virtually unsurvivable for anyone caught within them. Lahars are volcanic mudflows. They occur when volcanic ash and debris mix with water, often from melted snow and ice on the volcano's summit, or from heavy rainfall. These can be incredibly destructive, flowing rapidly down river valleys, burying towns and infrastructure under a thick layer of mud and rock. Less common, but equally devastating, are tsunamis triggered by volcanic activity. If a large section of a volcano collapses into the ocean, or if a submarine eruption displaces a significant amount of water, massive waves can be generated. The 2018 Anak Krakatau event in Indonesia is a recent example, where a flank collapse generated a deadly tsunami. The scale of these events varies dramatically. Some eruptions are relatively minor, posing local hazards. Others, like the eruption of Mount Tambora in 1815, can have global impacts, even affecting climate patterns worldwide by injecting vast amounts of aerosols into the stratosphere. These aerosols can reflect sunlight, leading to global cooling. Volcanic eruptions matter for several profound reasons. Firstly, they are a fundamental force shaping our planet. They build mountains, create new islands, and contribute to the composition of our atmosphere and oceans over geological timescales. The very ground we stand on often owes its existence to past volcanic activity. Secondly, they pose significant hazards to human populations. Millions of people live near active volcanoes. Understanding volcanic processes and improving monitoring systems are crucial for risk mitigation. Early warning systems, evacuation plans, and careful land use planning can save countless lives. Economically, eruptions can cause widespread disruption. Airports close, supply chains are interrupted, and agricultural land can be rendered unusable for years. Rebuilding infrastructure and economies after a major eruption is an immense challenge. Yet, there are also benefits. Volcanic soils are often incredibly fertile, supporting rich agricultural regions. Geothermal energy, harnessed from the Earth's internal heat, is a clean, renewable power source often found in volcanically active areas. The unique ecosystems around volcanoes, adapted to extreme conditions, are also subjects of scientific fascination. Volcanoes remind us of our planet's power and fragility. They are laboratories for scientists, sources of wonder, and sometimes instruments of destruction. Living with them requires respect, knowledge, and preparedness. When the Earth breathes fire, it is a spectacle of immense power and beauty. These eruptions are not random acts. They are integral parts of our planet's ongoing geological story. By understanding their mechanisms, respecting their force, and continuously learning from them, we can better coexist with these magnificent, fiery giants that remind us how truly alive our world is.